That simple sheet of paper begins with trees, water, and millions of tiny fibers working together inside a massive factory. Most paper starts with carefully selected wood from managed forests, although recycled paper can also supply valuable fibers. Different wood species provide different fibers, allowing manufacturers to balance strength, smoothness, brightness, and the final paper's performance. Once the logs arrive, giant machines strip away bark and prepare clean wood for the next critical transformation. Powerful rotating knives then cut those logs into uniform chips, making the wood easier to process evenly. Screens separate oversized and undersized chips, because consistent size helps the next chemical process work more efficiently. Now the real transformation begins, as those chips enter huge digesters filled with heat, water, pressure, and chemicals. Inside, alkaline chemicals break down lignin, the natural material holding wood together, while valuable cellulose fibers remain. What emerges is pulp, a wet mass of liberated fibers, mixed with dark spent chemicals that must be separated. The pulp then passes through washing and screening systems that remove chemicals, dirt, knots, and unwanted debris. For bright paper, the cleaned pulp receives controlled bleaching that removes remaining color-producing compounds from the fibers. Finally, the clean fibers are refined and mixed with water, preparing them for the moment paper truly begins. And now comes the incredible part. This watery mixture is about to become a continuous sheet of paper. At first, it looks like little more than cloudy water, but millions of fibers are already forming the sheet. Vacuum boxes underneath the wire pull water away rapidly, leaving behind an increasingly connected layer of fibers. The fragile web then enters pressing rolls, where mechanical pressure removes even more water and brings fibers closer together. The fragile web then enters pressing rolls, where mechanical pressure removes even more water and brings fibers closer together. But the sheet still contains substantial moisture, so its next destination is a long series of heated drying cylinders. Heat evaporates the remaining water, transforming the soft web into a continuous sheet with the strength and feel of paper. Sensors constantly monitor moisture and temperature, helping the machine maintain a stable sheet instead of producing weak spots. Depending on its purpose, the paper may receive starch or coating that changes its. That coating can make paper smoother, brighter, more printable, or better suited for packaging and specialized applications. Next, enormous calendar rollers gently compress the sheet, creating the smoothness and thickness required for its final purpose. And this is where the transformation becomes obvious. A thin, perfectly continuous surface now races through the factory. Before production ends, advanced inspection systems scan the moving sheet for tiny defects invisible to the human eye. Before production ends, advanced inspection systems scan the moving sheet for tiny defects invisible to the human eye. But making a sheet is only half the challenge. The factory still has to prove every meter meets the required standard. Now the finished paper faces its toughest test. Machines must prove that every section meets the required. High-speed cameras search for holes, wrinkles, spots, streaks, and other imperfections while the paper moves continuously. Sensors also measure moisture, thickness, weight, and other properties, keeping the paper consistent from beginning to end. Samples leave the production line for laboratory testing, where technicians check strength, smoothness, brightness, and printing performance. One simple test pulls the paper until it breaks, revealing how much force its fiber network can withstand. If the results fall outside specifications, engineers trace the problem back through the machine before more paper gets affected. Sometimes advanced automation catches the problem first, but experienced workers still decide what action the machine should take. Once approved, the enormous paper web travels toward one of the factory's most impressive machines, the giant reel winder. The winder carefully divides the enormous web into controlled rolls, maintaining precise tension so the paper stays perfectly aligned. Precision cutting creates the exact roll widths or sheet sizes customers need, turning factory-scale production into usable paper products. Robotic systems then move heavy rolls and finished stacks safely, reducing manual handling inside the busy factory. Protective wrapping keeps finished paper clean and dry while labels identify its grade, size, weight, and destination. But the factory's work isn't finished yet. The paper must now leave this massive mill and reach industries worldwide. From the mill, finished paper travels by trucks, trains, and ships toward printers, factories, stores, and businesses worldwide. Those rolls can eventually become books, newspapers, boxes, tissues, labels, notebooks, and countless products we use every day. And suddenly, something that began as wood fibers becomes part of ordinary moments we barely notice. The next time you hold paper, remember its journey, from forest and fibers to machines, precision, and the finished sheet. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video. From forests to finished sheets, every stage combines nature, chemistry, machinery, and human precision to create everyday paper. What looks simple in your hands represents an extraordinary chain of engineering, precision, and carefully controlled transformation. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video. Subscribe to the channel and we'll see you inside the next factory.